Okay, so good evening, everyone. Hope everybody has joined. So today, just a quick recap of what we have covered till yesterday. So yesterday, it's a new class a new begin for the new resources and all. So we are here for the data engineering basic crash courses. And yesterday, we just learned what is data actually and what are the various representation of data. So specifically, there are relational database which should be in format of columnar structure. Table column structure should be there, and the data should be pushed to the table as per the records. Okay, so how many records should be there? We can say those are the row numbers. Those are the rows in the particular table. So this is the entire structure for storing the data. It's what is maintaining by this system. It's called RDBMS, that is Relational Database Management System. We also learn some technique for keeping up relationship between multiple tables. Okay, so that is why it's relational database management system. There is also NoSQL part, a non-relational database, where we can keep key value pair and we can add any kind of data over there quickly without adding any columnar structure or anything. So this is one another kind of data structure and all. So we also learned that stuffs, and we also whatever we have also learned graphical visualization of the same data. So that three topics we have covered yesterday. So we have picked up only RDBMS for our future courses. So today onwards we'll be going ahead with RDBMS only. Okay, so what is RDBMS? I'm just repeating, it's Relational Database Management System. So first of all, today we'll be learning normalization. Okay, so normalization is, I mean, uh, what to do with the data actually. We can store the data inside a table in any way. Okay, without maintaining the normalization or not denormalization, anything. So what is normalization and how to keep the denormalized one to normalization? That thing we'll be learning by today's session. Okay, and why normalization is required? You can say it's to make it a meaningful data. When we are doing maybe if we are having, we have entered in a shopping mall. So in the shopping mall, they have get our details. The particular uh, the employees of the shopping mall, they are getting all the details, phone number, address, uh, particular employee's number and all inside their transactional system. And they are storing the data into some databases over there. Correct? So while storing the data inside their databases, they actually at the beginning of the time the thing is not meaningful way they are storing it. They are storing in either way. They are putting any column name. Maybe only one table should be there, and they are putting multiple column names over there, and they are inserting data over there. But this is not a meaningful way to store the data. The table should be denormalization in nature. So that normalization we have to make in further processing of data. We'll be learning how to further process from source system to target. That we'll be learning after a few days. But today we'll be learning how to normalize the data. Okay, what is normalization and all? So I will be showing you with a hands-on Excel. I'll be taking this Excel as our data source for today. Okay, so not this one actually. I have prepared another one. This one. Yes, this is fine. So just try to learn the things for normalization. It's a bit complicated. If you are in stuck in any position while understanding the thing, please stop me and ask me the questions. Oh, okay. Otherwise, I'll be telling you after finishing the slide. I'll be telling you if there is any doubt. Can immediately tell me. I'll be trying to repeat myself, or I'll try to simplify it. Okay. So this is the first table. Whatever we are storing from the source system. Suppose that particular table I'm receiving it from one of the teacher or maybe principal. school principal. Suppose I'm a data operator. I received this kind of table from one of the school's principal. Okay. So what is the thing? So I'm getting student ID, student name, course ID, course fee. Rather, I can say it, I got this thing from class teacher. Okay. So student ID is 11, Pankaj. Particular course ID is there. A course fee is there. The same kind of stuffs. Same kind of thing is there, but it is not a normalized way to store the data over here. Why it's not normalized? So we can say that the record. Okay, this record. I'm just highlighting it, and this record. It's duplicate in nature. There is no difference between these two records. You can see. So the table is consuming a duplicate record, which should not be the case. The record should not be duplicated. There should be only one record for each scenarios. So just like if we want to make it a normalized one, we need to remove the duplicate from the table. Okay. So this is the first thing, data normalization. So data normalization, there are various process. We'll be learning over here first normalization method, second normalization method. Okay. So first of all, whatever data we are receiving, we need to go ahead with first normalization form. This is a terminology only. We have to go ahead first normal form, then second normal form. After we achieve the second normal form, we can say the final tables are normalized in nature. Fine. So I'm going to this slide again. So from the denormalized table to make it a normalized one, rather I can say first normal form. First step is we need to remove the duplicates. Okay. I have to remove the duplicates. What should be the resultant thing? It should be only this. Okay. This is our first step. I have removed student ID 12 again because this is duplicated in nature. Okay. Now, another thing should be there. Okay. Let me just go ahead with this one. Each cell should contain a single value. Over there, we can see the course ID column. It's picking up for this row. It's picking up two different number or two different value separated by comma. Okay. This is also denormalized in nature. That should not be the scenario. Each cell should be contain only one value. Okay. So I need to split this thing in a separate record. So from this table, just go to this table. Over there, 11 is fine. Course ID is A11, course fee is 500. That is fine. For Sonu, I have splitted the thing into two records. Okay. A12, 800. For A13, it's 300 course fee. So I have splitted this thing, but this is not duplicated in nature. The duplication thing is coming till student ID and student name. But the main fact, when it's starting with course ID and course fee, it's not duplicated. So the entire combination of student ID, student name, course ID, course fee is unique. The same thing I can do for Raj, student ID 13. Okay, I have splitted this thing up. So now I can say this table is in first normal form, 1NF. Okay. But it is not totally normalized. We need to check the criteria whether we have achieved for the second normalized form. Let me check how to do that thing. It's a bit complicated. First normal form is very easy. So let me quickly clarify the thing once more time. So why we need normalization? Those are the things. We cannot give an entry for the duplicate record. And there is various process to remove the duplicates and all. When we'll be learning SQL stuffs, we'll be checking what are the ways to remove the duplicates and all. Okay. And if we store the duplicates as well, the data spaces or the table sizes should be big, which should not be the scenario. and we cannot go ahead with when we'll be adding up or summing up, or maybe we will be aggregating the thing, we can have the error as well while we'll be counting the duplicates and all. So there are two things. We can avoid the issues, and we can use smaller size of database, okay, to after removing the duplicates. And if we make it the normalized one, the calculation or the particular analysis on top of the table should be very much faster, and it should be very much easy as well. This is the causes, why we make the tables as the normalized one while storing the data. Okay, now for the first normal form, how to do that thing? There are two processes. Each cell should contain a single value. This is one process, and each record should be unique. Okay, so these two things should be there. Those are the two rules to make a table a normalized one. Okay, so first rule is we need to make each of the record unique, and the second rules is a particular cell cannot contain multiple values. If this thing happens, then we need to split the thing into another row or another record. Okay, now our table is first normal form. It's in first normal form, this one. And now we have to go ahead with the second normal form. So what is the technique for second normal form? So the rule is the table should be in first normal form, then only you can go ahead with second normal form. And what is the main step? Removal of partial dependency. Okay, so we can say, what is the thing over there in the particular table in first normal form? So suppose this is a identifier, row identifier. Student ID is the row identifier. So we need to check what are the columns which are not exactly dependent on student ID. So particular thing, student ID, Pankaj. Pankaj must be dependent. Student name must be dependent on student ID. That is fine. Course ID must be dependent on student ID because we need to check a particular student is taking which particular courses. Okay. But over there we can see course fee is not totally dependent on student ID. Rather, it's a partial dependency. So that's why we have splitted course fee into another table. By the example, I think you can get it. So only these three column I have put it over here. Okay. And course fee is directly dependent on course ID only. So I have splitted this thing into another table. This one. Fine. So I have splitted this entire table into two data set. Over there we can see if we split it, then course ID should be identified for this particular table. And we can see there are duplicates as well. A11500, A11500, because the same subject has been taken by multiple students. Then the same course fee should be there. That's why I have splitted it over there. Now we need to remove the duplicates as well. So we have removed the duplicates, and this is the another table after removing the duplicates. Okay, so I have just kept A11500, A1. We have removed this A11, and again from A14, it's been present over here for 2 times. I have removed this thing. So only unique value should be there. Okay. So I have created another table over here. One is course table, one is student table. So when anything is required, suppose Pankaj is paying how many, what are the, how much fees he should be paying. So we need to check Pankaj. Pankaj is present only once, and his course ID is A11. We need to check with the second table, A11. Course fee should be 500. So he should be paying 500. Suppose for Sonu is having two subject, A1 to A13. We have to go over here, A1 to A13. It is 800, 300. So while retrieving the data, we have to add it and come back away. Come back over here. So calculation should be done by this way, but we need to join this thing. The entire thing can be done with a single select query. We need to learn how to join between these two tables and how to aggregate things. How to sum the particular records. That's the thing we need to learn. Okay, that thing we'll be learning when we'll be going ahead with SQL part and all. Okay, so now these two tables, student table and course table, are normalized in nature. First of all, we received this one, denormalized table. Now we can say our tables are normalized in nature. So this is the way we have we have made it as a second normal form, the combination of two tables. Any doubt from anyone to understand what is normalization process? In our database, when we'll be creating data mart or data warehouse, whatever data we'll be receiving from the source system, we need to make it in normalized form. Okay. The same thing I want to give you an example from yesterday's while showing the relational database or relational table. There we have showed to you the product table, the customer table over there. There are separate identifiers. There was foreign key and primary key, and based on that, we can join. So primary key, foreign key should be present when we will be normalize the table. Otherwise, we cannot join or cannot set a relationship between two tables. Okay. So this is the way we can prepare it as a normalized table. Any doubt from anyone? Nothing? Okay, cool. That is fine. So moving ahead with the next topic. Okay, that is one more important stuff. Keys in SQL. Okay, so actually we can say there are two important concepts for key, primary key and foreign key. Composite key is a different one. I'll be just showing you the thing. Primary key, I already told you, for a particular table, the particular column which is unique in nature. Okay, and rather I can say particular set of columns is also eligible to be a primary key. Okay, and foreign key is okay, let me show you. So for this table, after normalization of this table, student ID is not a primary key alone, because student ID is not unique in nature. Okay, so we can say okay, we can say student ID over here. Student ID 12 is repeating in nature, because to make it a first normal form, we have splitted these two things. That's why 12 is present twice. This particular column, this particular table, we can say student ID is unique in nature. This table. Okay, we did not split this course IDs. So over there, we can say student ID is a primary key for this particular table. But when we are normalizing it as the first normal form procedure, we can say that the rows has been splitted up, because the course IDs are, one particular student is having multiple course IDs. Okay. So over here in this kind of scenario, we can say the combination of student ID and course ID is a primary key. So 11A11, this combination is not repetitive in nature in this table, because one student ID, one course ID is a combination that cannot be duplicated over here. So here comes the concept of composite key, a set of columns to be uniquely defined as the row identifier of the table. So combination of student ID and course ID is a composite key, and we can say this composite key is the primary key of this particular table. Okay. So same thing for this table as well. Student ID and course ID, combination of this thing is the primary key. And for this table, course ID and course fee, course ID is the primary key of this table. Okay. Hopefully you have understood what is primary key. Sometimes we can get a single column for the primary key. Sometimes that could be happen, or not only one single column, maybe multiple columns, 2, 3. So The combination of those things is called composite key, and that composite key may be the primary key as well. Okay. So that is why that's the concept of primary key. I mean, composite key, how it comes. Now, what is foreign key? I have mentioned it earlier. Okay. So for the course ID, it's a primary key over here. So when I'll be joining the data with this table, okay, I have to check the common column. So course ID is a common column between these two table. So I'll be joining course ID over here. So only course ID for this table is a foreign key respective to this course table. Okay, course ID is a foreign key in the student table now, respective for this course table. While defining the foreign key, we need to check what is the foreign table first. So the unique key of this foreign table, and that key is present in the primary table. If this is the scenario, we can tell that this is the foreign key concept or foreign key. Okay. Hopefully that is understandable for everyone. Any doubt? What is primary key, composite key, foreign key? No doubt? Okay. So, as we told yesterday that our data should not be stored in Excel format. Rather, we should be using databases. Okay. So now it's the concept to learn database. We'll be entering inside the database. We'll be creating tables inside the database, and then we'll be manipulating the data. We'll be analyze the data from the table by writing SQL languages and all. So today we'll be just touching what is database, how to install it quickly. So first of all, we will be database is just for storing the data, obviously. And over here, for the hands-on purpose, we'll be learning MySQL database. There's lots of database available in the market, but this is the open source database, and it's free for installation and all. I'll be giving you the link to install it. And the installation is very simple. It will hardly take 10 to 15 minutes to install in your machine. So install MySQL database. Let me open MySQL. So if we install MySQL database, then that kind of software is useful, MySQL Workbench. So it's a UI, user interface to access the database. And this is our database. If we just try to connect the database, that should be, it will require the password authentication. So while installing or set up your database, it will be requiring the password from you. Okay. So now inside my database. Okay. So inside my database, I have created those schemas. Schema means inside the database, I can create based on different subject areas, we can split the database inside multiple schemas. Okay. Suppose I'm just storing the IT information of a particular banking and finance sector. So I have credit, I have debit, all kind of transactions are there. So I'll be creating debit schema to store all kind of debit related transaction. I can create, particular credit related information in credit schemas and all. So that's why I have also created Teradata training purpose, this kind of schema. Whatever we'll be doing for these courses, I'll be doing this thing inside this particular schema. Okay, that is called schema. How to create the schema? We can do this thing over here. Right click over there with any of the schema. I can create the schema, I can alter the schema, I can drop the schema, anything. I can create the schema, put the schema name over here, apply, next. You just need to submit for the final confirmation. So it should be your schema creation. Okay, let me show you quickly how to do that thing. So new schema, it's fine. I'm not changing anything. Apply. Okay. If we just go ahead with command line prompt, the SQL query for creating schema should be create is a keyword schema, then the user defined schema name. Okay, just I need to apply. You can see this is the new schema has been created. Okay, now if I want to drop it, I can push the command drop schema name. Drop is a keyword, schema is a keyword, and schema name, what schema I need to drop. We can also do the command, user interface, the same thing, drop schema. I've selected the thing, right click on there, drop schema, drop now. Okay. So I created this thing for our training purpose. Our company's Tetra will be just starting implementing the thing, or will be creating the tables. I'll be cleaning all those tables. Those are created for the previous course purpose. I'll be cleaning this thing, all the tables by tomorrow. And it will be totally cleaned. And tomorrow onwards, we'll be working inside the schema, how to create the schemas and all those kind of stuffs. But the thing is, the database is there already in my system. I can access the database by command line prompt as well. There are something just like, let me show you. MySQL. Okay, MySQL shell is there. So we can just like pull shell script. Put shell script. There is no such UI things. Whoever is very much expert, they can directly just like put create schema name. Okay, new schema over here. It will be creating the schema. If I just execute it, enter it. The same thing I can do by putting this thing over here. Create schema name. Okay. Schema name is the particular name. Suppose 1, 2, 3. Schema name underscore 1, 2, 3. Okay. A new schema should be created with this name. So we can execute this thing over here as well. And we can enter the thing over here as well. But going forward, we will not be using the shell. We can use this user interface in our organization as well. We can use this thing and we can type SQL queries, this kind of command line over here, and we can execute this button. After writing everything, it's like select is a keyword for selecting a particular table. Whatever we'll be typing, we just have to select and execute this command, and we can find the output over here. Okay, so this is the way to typing the query and get the output. We'll be learning all those stuffs very quickly. Maybe from tomorrow onwards, how to execute a SQL query, how to create the tables, how to alter table structures and all. There are various kind of languages actually available. So tomorrow onwards, we'll be starting our first query languages. And first of all, we'll be learning what are the difference between variety of languages inside the SQL itself. And then we'll be going at one by one. So just to give you some more concepts on database, actually we have only picked up MySQL. Maybe in your project, or maybe when you have assigned to one of the project or application for your work, you can see it's not MySQL, it's a different database. As I told you, in market, there is lots of databases available. So, when we'll be doing the work, it should be the enterprise version of the databases as well. There may be variety of features. This MySQL is open source. So maybe you will be installing, or maybe inside your system when you are onboarding in a project, you can see this kind of databases. Oracle is there, Microsoft SQL Server is there, Teradata is there, Postgres are there, Sybase is there, DB2 is there, Redshift is there, Aurora database is there. So those kind of stuffs are available over there. But the main functionality or main functional knowledge is same for all the database. Maybe a bit change in the SQL query itself, the language itself. Even I can rather say the language cannot be directly modified. Some inbuilt function naming convention is modified over there when I'm differing from one query, one database to another database. But it's very minimal. You can learn every functional thing in MySQL by this course, and you can have a clear picture what can be the modified things, and then you can search it in the web as well. If you are learning only one database, maybe you are learning a different database as well, you have cleared your basics, then it's very simple to find. If your query is not running into other database for some functional issue, I mean not functional, I mean the syntactical issue, then you can quickly modify it by checking the thing from your web. Okay, but the main functional knowledge should be with you. Otherwise, you cannot check what to search with and those stuffs. Okay, so for our courses, we have chosen MySQL over here because this is a free source, I mean open source free tool, and it's very minimal in size for practice purpose. Okay, let me paste you the link and let me show you what needs to be installed. Okay, let me paste the same thing to the chat. Okay, so download the second installer, the big one, from this link. Okay, so after downloading it, then try to install it. Just double click over there, follow the steps. It's very simple, nothing complex over there. Just you have to next. At the end of the thing, just you need to set up a password for your user account, and that password is required for each kind. I mean, each time when you'll be logging to this database. Okay, I'll be also presenting a video. I created a video for the last season. I'll be pasting the same thing in your WhatsApp group. In a WhatsApp group, just one things needs to be modified. The links was not good over there. Whatever it was presented inside the video. So the link it's not fine for that video. So just keep this link, download this. After downloading, just follow the video. Okay, so that's the request. Okay, try to install it by today or tomorrow before tomorrow's class, because tomorrow's class it's totally the SQL perspective. We'll be creating tables, we'll be altering the table structure and all. We'll be learning what is DDL, what is DMS and all for tomorrow's session. So those are the things for database now. Okay, what is database schema? I already covered it. So those are called database schema. It's not very complex. It's just splitting the database into various subject areas. Okay, based on various subject areas, we can split the storage area of the database in schema format. Those are called schema. Excuse me. Okay, now the next topic is what are various database objects. So when we'll be inside a database, okay, suppose this is our database. Inside the database, there are schemas. If we just click on the drop down, you can see those are the tables. Tables is the unique, I mean, it's a basic unit for storing the data. Customer is a table, customer new is a table. So if we just click on one of the table, any one of the table, we can see those are different column. Okay, those are different column, and there are indexes as well. Okay, those are columns. Sorry, I'm creating on columns. Inside the table, index is present as well. Just like in our page, various index should be there. So over here, indexing thing is also there. The keys constant we can present over there as well. Foreign key, primary key. We can impose those kind of constraint on top of a particular table. Okay, I'm operating everything on customer table only. I'm just repeating it's once more time. Customer table. Okay, this is customer table. I'm clicking on this drop down button. It's split it up. Click on columns. The table should be comprising with this kind of column name: customer ID, name, purchase date, product type, outlet code. Okay. A particular index is present over there. What is index? I'll be covering this thing later. Foreign key constraint has been present over there. Trigger is there. Okay. So those are all database components. Even without tables, we are having views to store data. We have stored procedures to store data. We have user-defined function. There are inbuilt functions available, obviously. There are some user-defined functions are also present over there. So this is called user-defined functions. Okay. So those are the all different database objects. Table is the main or the most important thing. It's the basic unit of storage, and comprising of table we can create the view, their sequence as well. Indexing part I just showed to you. Synonym is also there. So after covering the table thing, from tomorrow onwards, we will covering the other stuffs in the very next step. Okay. So those are all database objects. Not only table is the database objects, those are all the database objects. We'll be learning what are the things day by day. Okay. So I think we are almost end of today. So from tomorrow onwards, it will be a bit interesting because we will be doing the hands-on exercise on top of this database languages. Okay, we'll be learning select query. We'll be learning the queries as well. We'll be creating the tables. We'll be manipulating the tables. So lots of interesting things should be happen from tomorrow onwards, and that should be also helpful for you to answer the questions at interview site on top of SQLs and all. Okay, so yeah, that's all for today. Whatever we have planned. So any doubt from anyone till now for the intersection normalization, what is database and all? Yeah, Nitesh, first. Any doubt? Not able to hear your voice. Hello. Am I audible properly for everyone?
Yes.
Okay, maybe some issue with your mic, Nitesh. So maybe you can fix it, and if there is anything, you can put it in your chat. Not sure what is happening. Okay, so if there is no doubt, let's connect tomorrow. Just a request: install the MySQL database to your system. Otherwise, you cannot learn. Daily basis. Just learn it and try to execute the thing at your own way in MySQL, and that should be fine. You can remember the process, what to do next step, and what are the steps exactly on the SQL side. Okay. Okay, then let's connect tomorrow. Or okay, I found some chat here. Okay, difference between schema and database. So the schema I just told you over here, we can split the subject area. Actually, schema is been useful for the table structure. Schema is, different purpose. We can use schemas as well. While learning that particular data modeling chapter, maybe after 1 week, we can found a schema there as well, but it's a different schema. Over here, whatever we are using over here, we can say database. For various subject areas, we can split the database into various schemas. Okay. Over there, we can also say data training purpose, it's a database as well. In MySQL database, this is another kind of database as well. But we are splitting this thing as per our subject areas. So this is called schemas. And schema name should be unique. Over there, I cannot create another schema just like data training purpose again, because this is already present, already available in my MySQL instance. Okay. One more thing, when will be, suppose I'm working in a big company, the creation of the schemas and all, that should not be in our control actually. That should be created from the DBA. There should be someone who will be owning that database. They are the administrator of this database. So, and will be data engineers. Okay. So if you just entered in the data engineers post over there, if this is a big company, then we will not be managing the database from our side to do any kind of database patching activity, to create any kind of schema, to give anyone's access to the schema and all. We should not be responsible for. There should be an administration team. They will be creating the schema. If we request them for a particular purpose, we need the schemas to be created. They will be creating the schema for us. We should not having the permission of create schema name. This command execution. Okay, there will be an error shown over there that you do not have privilege to run this schema creation statement and all. Over here, I have installed this particular database. I am the DBA. Even I'm working as a database engineer as well. So that's why I can create it over here. But when we'll be working as a database engineer team, if this is a big company, if that is not owned by us, then there should be a separate team for managing those kind of stuffs. We'll be just doing the tabular, I mean, whatever table needs to be created, we can create this thing. We can modify this thing by our own. We can manipulate the data over there. This should be done by us. Okay. So that's the overall concept. Let's go ahead with one by one. I mean, very next day, then the thing should be more clear. Okay. Is normalized done manually? How it can be done? Yeah, is normalized can be done manually. We can do, but it should not be. There are various ETL process. When you'll be learning SQL stuffs, there are ETL tool as well. We will be learning BI process, business intelligence, and all for large data set. We will not be doing this thing manually. So there are various tools available that is called ETL. So Python will be using as a ETL tool as well. So we'll be learning how to do that thing in next chapters. ETL is extract, transform, load, ETL tool. Okay, there are various ETL tools are available, just like Informatica, Talent. Okay, so nowadays we are not using the tools as well. We are using some languages, Java, Python. We are creating some frameworks on those open source languages, and by using these frameworks, we can load the data as well. We can normalize these things from our own way. Even we can write the SQL queries as well. We are not using any tools. Rather, we can use the SQL queries, various SQL queries to represent various normalization process. We can come this thing later. Maybe tomorrow onwards, we will be learning the basic SQL stuffs. After that, maybe at the end of the session, not end of the session, after end of the SQL session, we'll be learning the business intelligence process. There we'll be covering up again how to create the data marts and data warehouse. And while creating the data marts and data warehouse, we need to think about the normalization process. Then I'll be mentioning those ETL tools names and how to do this thing, a basic and overall concepts on top of that one. Okay. Okay, then that's all for today. Let's connect tomorrow for more detailed session. Thanks everyone. Bye bye. Have a great day.